Hello, General Biology, and welcome to the fourth. Wow, this section's having a lot of screencasts. The fourth screencast in the Chapter 2-1 series. And we were talking about ionic bonds in our last little clip, so let's conclude those so that we can get on to covalent bonds. So when ionic bonds form between sodium and chlorine, they form sodium chloride, which is table salt. And we can see that sodium becomes a positively charged ion and chlorine becomes a negatively charged ion. And the reason is because sodium loses that electron that was in this valence, and chlorine gains that electron that is in its valence. So anytime you have a transfer of electrons, so remember when, and let's draw hydrogen this time. I have hydrogen. Hydrogen has an atomic mass of 1.01. It has atomic number of 1. And then in the corner, it can gain or lose electrons. So the little plus and minus sign will tell you whether it can gain or lose electrons. Sodium, for sodium, let me erase that and do that again, okay, so I can get rid of that line. Sodium, all right, if we were to look at that at the periodic table of elements, sodium has an atomic mass of around 22. There's those lines again. The proton number is 11, so the atomic number is 11. And because it can gain or lose electrons, it's going to have a positive sign. And it typically loses 1 electron in that valence electron. Okay, so that's one of the things that you would see on that periodic table of elements. So a sodium ion atom easily loses its 1 valence electron to become positive. So that's just reinforcing what I just said. Notice between here and here, we had 3 energy levels where we only have 2 energy levels there. Chlorine atom easily gains an electron from the sodium and becomes chloride by gaining that. So here we had 7 valence electrons. Over here we have 8 valence electrons. These oppositely charged ions have a strong attraction for each other, and because of that it forms the ionic bond to make sodium chloride. Okay, so you have to be able to tell the difference of whether an ion is a positively charged ion or a negatively charged ion. And of course in science we give them terms. So a cation is an atom or a molecule which is positively charged. That means it's going to lose an electron. And an anion, anytime we have a before it, means without. So an anion means that it's going to gain or be negative an electron. So one of the ways that you can remember this is a cations, they're positively charged. Or an anion, AN, a negative ion, is another way to remember that. So again, make yourself familiar with those terms. Now covalent bonds are a little bit different because they share electrons instead of transferring them. The electrons will travel about the nuclei of both atoms to form a covalent bond. So let's take a look at water molecule, which I believe is the next picture that we have. So here, if this is the electron from the hydrogen, what's going to happen is it's going to spend some time spinning around here, and then it's going to spend some time spinning around the oxygen, and sometimes spinning around the other hydrogen, and it's going to continue this path like this. So instead of it losing the electrons, it's going to share the electrons. So hydrogens each have 1 electron, oxygen has 6. Remember we want that octet rule, we have 8. So that's why the hydrogen, you have 2 hydrogens, so that they can complete the 6 valence electrons. Since I feel like that's a little bit unclear, let me erase that. Okay, and we'll talk about this again. Oxygen has 6 valence electrons. So let's look at those. 1, 2, 3, 4, 5, 6. Hydrogen, we have 2 of them, has 1 valence electron. All right, so here's the 1 valence, here's the 1 valence. The octet rule for sharing means that there's going to be 8. So this hydrogen is going to share its only electron, and this hydrogen is going to share its only electron, so that we have 1, 2, 3, 4, 5, 6, 7, 8 electrons in that outer energy level. And as I said, this electron will spend some time spinning in the orbit of the hydrogen, then it'll spin in the orbit of the oxygen, and it'll spin in the orbit of the other hydrogen, and it will continue around like this, where the electrons are going to be shared and not exchanged. And that's what covalent bonding is. So when atoms of the same element join together, they also form a molecule. Oxygen molecules in the air that you breathe consist of 2 oxygen atoms, and they're joined by covalent bonds. We'll watch this video in this section in class. We have other types of attractions that you need to be familiar with. They're not necessarily electron attractions, but they're intermolecular forces, and that means in between molecules. And one of those is called van der Waals forces. And these are where molecules form a temporary weak bond between other molecules. So because atoms of different elements do not have the same ability to attract electrons, some atoms have a stronger attraction for electrons than other ones. And even when sharing is equal, there's a rapid movement of electrons that can create regions on a molecule that have a tiny positive or negative charge. And these are called van der Waals forces. So you're probably saying, Mrs. Saunders, I don't get it. Okay, so have you ever seen an insect be able to climb up a wall or across the ceiling? Okay, those are van der Waals forces. Spider-Man, you know, it has the tiny little hair-like structures that come out of his hands, and it allows him to attach to the wall and move up the wall. Those are van der Waals forces. Geckos, that's the way they walk. And we're going to see this video on van der Waals forces that we'll watch in class. The important thing to know is these are intermolecular forces. They're not between the electrons. And they're named after the scientist who discovered them. They're a very slight attraction, so they're not as strong as ionic or covalent bonds, and they can hold molecules together, especially when we're talking about large molecules such as the gecko and a wall or a glass. All right, that ends this section. We'll start section 2.2 in the next screencast.